Hey guys, it's Mr. Gilbert here for the morning of 210. We talked about specific heat in your notes yesterday, but we have not covered like an example problem, and I want to do that before you guys work on your worksheet today. So you have a short worksheet today. It's just 10 specific heat questions. It's in the assignment page with the date on it. Specific heat looks intimidating. There's a lot of units and there's 4 variables. It's really not that bad. It's really just multiplication of 3 variables. So I'm going to walk through the first and maybe the second example on the worksheet to give you an idea, to make sure we're on the right page. So let me open up my writing tool here. All right. So the first problem you have, so let me walk through the equation first real quick. So you have on the equation Q equals M times change in T times C. Now sometimes you'll see it written instead of that. You'll see Q equals M times TF minus TI times C. And the reason that is that delta T, triangle T here, is change in temperature. And so this is just final temperature minus initial temperature. That is to say, basically, if we go from, 24 degrees Celsius to 26 degrees Celsius, that's a change in temperature of 2 degrees. Or we could write 26 minus 24 here. And so what you'll see is that sometimes that can be negative, and basically that means, are we adding energy to it or taking energy away? So if I'm talking about a beaker of water, am I cooling it down, pulling energy away from it, or am I heating it up? Am I putting it over a Bunsen burner and warming it up so that it can get hotter? All right, so am I adding thermal energy or taking it away? So that's what the positive and negative in this tell you. So that's our formula. Q equals M delta T C. Q is the amount of energy. Energy we measure in joules. Now we have a unit coming up on energy, so we haven't spent a lot of time on that yet, but energy is joules. All right, so joules equals the mass, how many grams or kilograms, times the change in temperature times the specific heat. Now this specific heat is the specific heat of that specific material. So every material has its own number. And you'll see as you look through the problems, they all have one assigned. So basically, the higher the specific heat, the harder it is to change the temperature of that. So when we think of ideas like, is it a conductor or an insulator? And I told you guys in the lecture, there's not like, everything's not labeled as one or the other. We learn it black and white when we're younger, but it's not really that way. Everything has its own number assigned to it and how well it conducts heat. And so everything has its own specific heat number. And so if you look at your worksheet, you'll see that I have an equation in variables, and then below it I put an equation in units so you can see what it looks like. So I'll write that here as well. So this is joules is equal to grams times degrees Celsius times joules per gram degrees Celsius. Now this unit looks weird, but this is, so it looks odd to us, but I want to explain it. It's really not that bad. So this is energy. So how much energy, and always think of this as per, like when we do like speed limit, we say miles per hour. We treat that division sign in units as a per. Joules per mass, grams per temperature. So how much energy does it take to heat up that mass, that temperature? And so it should make sense. That's what specific heat is. How much energy do we need to heat up this much stuff by this much? All right, and so it's kind of logical. It looks kind of gross. Joules per gram degrees Celsius, but really not bad. Okay, so let's look at your first problem. I'm going to erase this bottom part here. Let me see here. I'm going to use this app in a moment. Well, it's going to take me a minute to erase. Let me try something else. There we go. All right. Just leave this equation up here so you guys can see it. And I'm gonna post another video of somebody else showing this too, in case you need extra help. So number 1 from the worksheet says, what is the specific heat of a substance that absorbs 2,500 joules Actually, I'm going to do number 2. Sorry, let me skip down to number 2 because it starts in the correct way. So if 200 grams of water is to be heated, so we want 200 grams of water. So 200 grams of water, that's my mass. If 200 grams of water is to be heated from 24 to 100, so 100 degrees Celsius minus 24 degrees Celsius, that's how much temperature is going to change. If 200 grams of water is going to be heated from 24 degrees Celsius to 100 degrees Celsius to make a cup of tea, how much heat must be added? The specific heat of water is 4.18 joules per gram degree Celsius. 4.18 joules, grams degrees Celsius. And that's going to equal Q, how much energy needs to be added. So what we're looking for is Q, how much energy. Alright, so really all I need to do is just multiply these three things once I simplify that middle section. So 200 grams times, this is going to be 76 degrees Celsius, times 4.18 joules grams degrees Celsius. Alright, so 276. So I'm going to pull up my calculator, which is right here. Actually, I'm going to throw it on here. I'm having trouble getting it to work. Bear with me for 1 second. And so I got a calculator opened up here. So 200 grams times 76 times 4.18 joules is what we're looking for. So let me quick here. There we go. So that comes out to equal 63,536. 63,536. Sorry, 1 second here. Sorry. So 63,000. I hit the wrong button again. There we go. 63,536 joules. And so if you're curious what that means, so we were talking about heating up 200 grams of water. So 200 grams is like 0.2 kilograms. So that's you're roughly looking at half a pound. To give you an Americanized idea of that, you're looking at roughly half a pound. And so half a pound, okay, half a pound of water. So I'm looking at like, maybe a cup or two of water, a couple cups of water. So I would heat that up by 74 degrees Celsius. And so that's pretty intense. Like that's right. I'm heating it from 24 to 200 to boiling. So to put it in our kind of, if you will, Americanized terms, I'm heating that up from what is room temperature-ish, like what temperature is in your house, to boiling. So that's like putting water on the stove, like getting it out of the sink, a couple cups of water, putting it on the stove and heating it to boiling. So that gives you an idea of what a joule is. 63,536 joules is what it would take to heat that water up. So a joule is not very much. It's a small energy quantity, so you get high numbers when it comes to joules. All right, let's look at one more. So that was number 2. If you feel like you got this well, then you can just go ahead and work on the worksheet. You don't have to watch this whole thing necessarily. Well, let's look at number 1 together. Okay, so for problem number 1, what is the specific heat? So we're looking for a different variable of a substance that absorbs 2,500 joules. 2,500 joules is equal to, of 100 grams, I want a sample of 100 grams, increases from 70 to 10, from 10 to 70. So times 70 minus 10 degrees Celsius times the specific heat. So to simplify that, I have 2,500 joules is equal to 100 grams times, and we're going from 10 to 70, so we're going up by 60 degrees Celsius. 60 degrees Celsius times C. So I'm going to simplify that one more time. 2,500 joules is equal to 6,000 grams times degrees Celsius times C. And so now I need to get C by itself. It's basic algebra. So I divide both sides by 6,000 grams degrees Celsius. 6,000 grams degrees Celsius. And I get C equals 6,000. I was having trouble opening my calculator while I had the app open earlier. I didn't have any problems with that back in the spring, but for some reason I'm having trouble now. 2,500 divided by 6,000, and you get 0.416. So 0.417. You get 0.417 joules per gram degrees Celsius. And that is my answer to that. Now, you can identify a substance by a specific heat, just like you can say melting point. So if we talk about, or freezing point or boiling point. So if we look at water has if we have a clear liquid and we go to boil it, and it boils at 100 degrees Celsius, and then we freeze it and it freezes at 0 degrees Celsius, you can go, oh, that's probably water. It's an identifier. It's a physical characteristics of that substance. You can do that with specific heat. And so if we can calculate the specific heat of a substance, we can go, oh, that's probably the substance. So this question doesn't tell you what the substance is. But if you look at question 2, which we've already done, the specific heat of water is 4.18 And so this is something that it heats up at a tenth, like 10 times faster than water, right? So water, if you look at water is 4.18 joules grams degrees Celsius. That's 10 times higher. And so we're looking at something that heats up really easily, 10 times easier, more easily than water. All right, to give you an idea. So there you have the first two problems solved for you. We did number 2 and number 1. I'm going to post this video as well as another video in case you're still having trouble. So tomorrow in class, assuming we're in person, I'll go over a couple of these. If not, I'll probably record a video going over a couple more. Let me know if you have questions. Have a good snow day.